Hello everyone, I'm going to talk about the 15 Powx and implement the I think I pronounce right. Powx n, which calculates the x raised to power n. For example, x and n means how many times x should x times x. So for example here, we have x is equal to 0.0, something like this, and is equal to 10, then which means like this 2 times 2 times 2 times 2, then equal to the 1024. Same thing as this, and also we have this one. So kind of like we have the two different situations. And another thing is if the for the like 2 0 here actually should be 1. So we need to check base conditions. If n is equal to 0, will we directly return 1? You can see here. Okay, so directly equal to 1. If not, we actually to double 1 here. And also for this one condition, if the minus, right, so which means actually is equal to this one. So we need to flap it. If x is smaller, if n smaller than 0, we should let it equal to -1. We have the double result. And for here, we can see the n, if out of this, right? It's definitely, we're out of boundary. We need to transfer the int into the like long. Equal to 0, then we can equal to x times the and divided by n and divided by the if n modified 2 is equal to 1, which means the last one, plus the x n equal to n minus 1. Here, like 10 divided by 2 is equal to 5. Oops. Oh, this one changed, but the move to the x is also changed x. I mean this minus here. Times x. Yeah. So we can follow the first example for here, right? So why the result should start from the 1, because NA will equal to the one time this one. If 0, everything calculate as we previous example, this one is output is 0. So we need to do this like 10 divided by 2 is equal to 5. For here it should be 4. And then keep next continue. Okay, if I is modified 2 is equal to 1. So we need the result equal to the 1 times the x. Currently is 4. And for here we modify n minus 1 is should be 4, and then keep continue to here. Then it will be the 8. Then here 4 should be 2. And then keep continue, right? Modify, it will be here, and times this one 46 1, and come here. Result should be the 4 times the 6. For here 0, and keep continue. This one x is what? X is 46 times 46. Oh my god, is how much? No, not this one. Yeah, definitely it's wrong. Okay, I think we can debug them way better. Okay, this one's changed 4 and this was 5. And yeah, this calculate for the should be 4. And for here is 4 times 4 is 60. Okay, 60, not, yeah, this one, 60. Then 2. Alright, 60 and 60 times 60. Or 24, this one. And then for here, the 1. To divide it should be 1, and then come here, it should be 4 times the 24, 5 here, and 1 here. And then it's work 0. It will not go in this loop, and it will, the result is already updated. So I would say treat like right, so for here is actually means the latex like this. Okay, let me show you. Right, actually it's equal to times 2 times 2 5. And then we calculate this one first run. Here, like this. And which means got 4, 5 here, right? And then keep continue. We 4 times 5, this one should be the one plus the 1 plus 4, and then which means 4 times 4 times 5. Okay, and then we keep continue to divide it by 4 here. It should be the 4 times, it should be 4. And then 4 times 2 plus 2. 2 times And then we can calculate this one. It's 4 times 6. Then go in here. And then we 4 times keep continue. Is how much? 16 is 254. And then we calculate this one, right? It should be 1024. So it's kind of like a math way to the first step we can see here is right 22 is matching for those process, kind of like a different way to express those process. Divides by 2, and for inside here is you can see here 24, the first step, right? This one and 5, and this one is kind of like a next loop, prepare for next time. 5 is not, right? So it's we're going here to use whatever the result to store the 4 here, and prepare for the next time to calculate them. Yeah. And I think the time complex, there's no extra space I took, and for the time is every time is divided by 2, so the worst would be the kind of like binary search, a binary tree. Open and space should be, I didn't create extra space. Ooh, wrong answer. Let me see what's going on. Okay, ln n. Okay, this one actually, okay, so we actually can need to move here to do this. Because for the minus computer like bit something, positive and negative, the bit of them is different. That's why that's the case not work. But if we do this before, then it will kind of like satisfy the end, because this one, right? Original is something here. I think a negative, the bit is more than the positive. So previous like minus something to that is when they translate to the positive one, it will be out of the boundary. That's why the last case not pass. Yeah, thank you.